We know that atoms are made out of protons, neutrons, and electrons. The things that determine what atom it is, what element it is the number of protons, and that's also represented by the atomic number. So if you go into this animation here, click play. You can get this from PhET. There's tons of them on this website, which is quite useful. We'll go to atom. And we're going to build an atom. Let's just reveal the net charge. So we know that atoms are made out of protons, neutrons, and electrons. And the periodic table is a list of all those atoms, all those different types of atoms, all those different elements. If I add a proton, it calls itself hydrogen. If I add another proton, it calls itself helium. So the protons are the only thing that determine what element it is. I can start adding neutrons, and that won't change what it's called. However, it does turn it into a different isotope. An isotope, think tope, sounds like type, so it's a different type of atom. So that's an isotope of helium, and that's an isotope of helium. Okay, but there are more. So if you want to change the element, then you would have to change the protons. Now, it calls itself an ion. An ion simply means a charged atom, or if you want, you can say an atom that has where the protons do not match the electrons. It doesn't have any electrons, so where it's got two protons. So if we give it two protons, then it's balanced out. The positive balance out with the negatives, and we have a neutral atom. If I take away the neutron, it's still a neutral atom. It's an isotope of helium. Okay, so there are different isotopes of helium. So the atomic number is what determines what element it is. It also tells you how many protons it is. And you have to have the same amount of protons as electrons, so the charges will then balance out. And the mass number is determined by the protons plus the neutrons. Didn't want that to happen. Right, so basically this is helium. It's got, so if I do helium there, then it's got a atomic number of 2, a mass number of 4. By the way, if your periodic table has them the numbers the other way around, there's no real right or wrong answer. There's probably a convention that most chemistry teachers, chemists would agree on, but many periodic tables go back and forth. So the main thing you want to know about is that is the largest number. The mass number is the largest number, and the atomic number is the smallest number. The atomic number tells you the number of protons, and the mass number tells you the number of protons plus neutrons. So if you want to calculate the number of neutrons, you're just going to do neutrons is going to be equal to the mass number take away the atomic number. Because the mass number is the number of protons and neutrons, you take away the atomic number, you reveal just the neutrons. So that's the basics of atomic structure. We also need to realize that you can only put 2 electrons in the first shell, and then you have to start filling up the second shell. It's now an ion again. So if I were to give it a neutron, a proton to balance it out, obviously it changes the name to lithium. And what you'll also notice is that lithium is on the first column, or the first group, so group 1, and it has 1 electron in the outer shell. So the group is what tells you the amount of electrons in the outer shell, and the period, or the row, tells you how many shells of electrons there are in total. This lithium has got 2 shells, so it's in period 2. And if you go back to helium that we had a moment ago, helium has got 2 in the outer shell, but it's not in group 2. It's in this group over here, which we call group 0, not group 8. The whole stuff in the middle, that's just all confusing. We're not going to worry about that. We sort of forget that that's there at GCSE a lot of the time, and it'll come up in A level. But for now, we just go 1, 2, and then 3, 4, 5, 6, 7, and then suddenly 0. So the reason why this is group 0, not group 8, is because it basically means it's got a full outer shell. So all atoms like to have full outer shells, and if they already have a full outer shell when they are a regular neutral atom, then they are very, very stable, very, very unreactive. They don't react with things, okay? And if it's really easy to give it a full outer shell, like lithium just had one electron in the outer shell, that would make lithium very reactive because it's very easy to make it a full outer shell. I just need to take away one electron.